Hello, and welcome to Summarize Science, where we break down the latest research. Have you ever noticed that when you ask an AI to generate a really large image, it can be slow or produce strange, repeating patterns? This is a common struggle for even the most powerful diffusion models. Generating at a low resolution and then upscaling the final picture can work, but as you can see here, it often adds unwanted noise or makes things look plasticky. This is because the upscaler is just guessing at details from pixels, not the original creative intent. This paper introduces a clever solution called the Latent Upscaler Adapter, or LUA. Instead of upscaling the final image, LUA is a lightweight module that works directly on the latent code. Think of it as the image's abstract blueprint, before the final decoding step. This is a much more efficient place to do the heavy lifting. LUA is trained using a special three-stage process. First, it learns to match the structure of a high-resolution blueprint. Then, it refines this by looking at the final pixel output to ensure consistency. Finally, it sharpens the edges in the pixel domain to get a crisp, clean result. This curriculum helps it create realistic details without introducing noise. So, how does it perform? The results are fantastic, especially for very large images. Looking at these tables, we can see that the SDXL plus LUA method is consistently one of the fastest options across all resolutions. For a huge 4096 pixel image, it takes just under 7 seconds, while direct generation takes over 148 seconds and other complex methods take over 90 seconds. But speed is useless without quality, and this is where LUA truly shines. In these side-by-side comparisons, you can see that direct high-resolution sampling can create bizarre artifacts, like duplicated crab legs or warped car reflections. Pixel space upscaling can look artificial and noisy. The method from the paper, SDXL plus LUA, produces clean, stable textures that preserve the original image's structure, all at the lowest runtime. One of the most practical discoveries is LUA's versatility. The researchers found that the same core adapter works across different major diffusion models, like Stable Diffusion 3 and Flux, with only minimal fine-tuning. This makes it a highly practical tool that can be easily deployed in many different systems. So, let's quickly recap what this all means. The researchers created a small, efficient adapter called LUA that plugs into existing AI image generators. It smartly upscales an image's hidden blueprint rather than the final pixels. This leads to massive, high-quality images that are generated much faster and with fewer artifacts than previous methods. This is a practical solution that makes high-resolution AI art more accessible and reliable. Looking to the future, this technique could be extended to high-resolution video generation or other image-to-image tasks, where maintaining fine detail during upscaling is critical. It represents a significant step towards scalable, high-fidelity image synthesis. Thanks for watching Summarize Science.